Homework Hotline, what is your emergency?
Over here we have a great question that I think many people can relate to. It asks, Wilbur wants to make a pond for his backyard bigger. It is currently a cone with a radius of 30 meters and a depth of 15 meters. He wants to increase the radius to 40 and the depth to 20. How much more water will the pond hold?
That's a great question. So that sounds like another volume question like Becca had answered before with the donuts. So really what we need to figure out here is how much the bigger pond is going to hold and how much the smaller pond already held, so we can calculate that difference. So if you come to my screen, I already threw the equation for the volume of a cone up. I threw it up here. It's a little bit nicer than I would have written it myself. Maybe I can make this a little bit bigger. So again, what we're looking for is the volume of the larger pond, and we want to basically subtract the volume of that smaller pond, and we can figure out from there how much more it holds. So if I could see again some of those numbers regarding the pond sizes, I can work through that. Antonio?
There it is.
All right, so again, this is the equation for the volume of a cone, which is related to the problem that you were asking. So what we're going to do first is kind of talk about some of the pieces. V is obviously for volume. R is going to be for the radius, which is a piece of information that was given to us. And H is for the height of the pond. So what I'm going to do is I'm actually going to turn this into two separate problems and then combine them in the end. I'm going to look at the volume, if I can write with this, the volume of the bigger pond. So I'll just call that BP. And then I'm going to also look at the volume of that smaller pond. And again, then we're going to look into the difference between those two. So if you think again about what this pond is looking like, it said it was a cone shape. Okay, so it looks something like this, kind of an odd shape for a pond, but it is what it is. So when we talk about the radius, we're talking about the distance from here to here. So in this volume formula, we have the radius r, and then we're also talking about this height right here. That's going to be our h. So again, all we do is we use the information given. So the bigger pond had a volume, or sorry, it had a radius of 30. So we'll call that r was 30. And it had a depth of 15. In this case, I told you the formula for a cone involved the height, but in this case, we're really kind of looking at this depth here. It's the same idea. So all we're going to do is plug this information in. So the volume of the bigger cone is going to be 1/3 pi, and we're plugging this in, r squared, so the radius squared, 30 squared, times the height, or in this case, we're talking about a pond, so the depth of that pond. We're going to do some simplifying here, so V equals 1/3 of pi times 900 times 15. And again, I'm probably going to need a calculator for this, so we'll come back to this in a second. Thank you. So when we're looking at the smaller pond, we'll do the same thing. So, oh, I did this backwards, actually. The smaller pond, sorry about that. This is actually the smaller pond I calculated right here. I got this information a little bit wrong. So we already calculated the volume, or we set up the volume for the smaller pond. This is going to be the bigger pond. There we go. So the bigger pond, the radius was 40, and it had a depth, or in this case, it's the height of 20. So same deal, we just set this up again, same way we did the other one. 1/3 times pi times our radius, 40 squared, times 20. And I'll simplify this a little bit as well. 1/3 pi times 1600 times 20. And again, what we're looking for is the difference, how much more volume your pond is going to hold. So really what we're looking for is the volume of the bigger pond minus the volume of that smaller pond. So I'm just going to punch this in my calculator. I'm going to do the bigger pond first. It was 1/3 times pi times 1600 times 20. and I get a volume of 33,510.32. That's the volume of the bigger pond right here. So same thing, I'm going to calculate now the volume of the smaller pond, so 1/3 times pi times 900 times 15. Oh, I did something wrong with my calculator here. So let me do this again, 0.333 times pi times 900 times 15. And I get a volume of that smaller pond. Where's this thing? Of 14,135.75. So again, now what we were looking for, look back at the question. He wanted to increase his pond. How much more water is that pond going to hold? So I'm just going to do this subtraction, 33,510.32 minus 14,135.75. So this pond is going to hold 19,374.57 cubic meters of water more. So we could say meters cubed. All right, so again, when we're looking for the difference, we actually have to do 2 volume problems and then find the difference between the 2 of those.